Hello, welcome back, and we are continuing the genetic algorithm for a Spotify playlist design, and we're continuing with the structure of it. Now, there are a few elements we're going to be covering today. Specifically, we're going to be focusing a good bit on the fitness function, the population size, and the selection size, as those are the more unique components. But we'll be talking also about taboo list selection. So, first off, we do need to discuss our gene, which is a binary array of the length of all of our data, which is assigned right here in this numGenes property. Because we're using basically a modified version of the knapsack problem, the gene just needs to be binary, and so we can also set the gene space to be a 0 or a 1. And it's pretty simple. As far as other things that are right here that you can see, we are using parent selection of a ranked selection, and then we are using a mutation type being inversion, so that just flips the bits, not keeps everything steady. And then it does try to keep one parent per child. That way it kind of reduces the population, allows us to multiply very rapidly. And then I just selected a arbitrary number up here for the number of parents, which is 2. And that could be increased. That's something that I am monitoring actively. But the biggest thing is the number of generations. I currently have that set just for testing to 1,000, but I will be raising that up a lot further, and we'll be increasing also the maximum population size over time. So the solutions per population is 100, and that could increase depending on how well the agent acts, most especially because we have 198 different inputs, which is our data. Now, the fitness function, though, we will also look at this. So this is designed to work with essentially tuning to the preferences of the user. So I made a preferences class, which basically contains if I want a value to be higher or lower than a specific value, what that specific value is, and how much variance I want to allow, which is basically it's going to widen a cone that a calculated preference will be added in. Then also a multiplier, so this is kind of like the priority of how much I really want this to affect the fitness function. Then right here, for each one of the preferences, it calculates the fitness of that specific element, and it's the multiplier times the value fitness, which is the variance times essentially the distance from the value we want. Normally this shows up as a spike, and it's commonly used with knapsack problems to calculate the size, or with finding a specific random value of finding that. Then we have high-low fitness. It just returns a 1 or 0 based on the whether it is above or below. This might be modified as to include some kind of multiplier value as well. Then we also have the variance times the variance divided by the mean. That way it also adds how much variance we want in a specific parameter. And these parameters are basically within the data itself. The data is basically fields that we can directly query from the Spotify API, then whether or not it's favorited, which I have to input if it's explicit, and its preference value. Then we have a year and seconds value. These are modulated to the 4-digit year, and then seconds because of how pandas data frames work. And this results in a pretty smooth calculation. Now the final fitness function actually shows up like this. So it's going to take us that binary series, that binary way, convert it to a series, and then it's going to, currently it's checking to see, this is me trying to implement the taboo list, which is in development at the moment. The taboo list is actually used in other playlist creations. I mentioned these in my survey. And then what it's going to do is it's going to sum the time first. If it goes over the time, it's going to return -1, which will likely be added to the on generation or the parent selection, to where if it's a -1, don't even use it. Don't bother, create something new, and then add that to our taboo list. The taboo list prevents us creating the same solution again and again, allowing us to speed up the entire process. And finally, it goes through and calculates everything else based on other values we put in, such as how many artists I would like to have, or how much having a variety of artists counts, how many favorites, the benefit of having a favorite, the benefit of having explicit or detriment as well. I have this set to a -10. And then also songs per artist value, which basically just allows for increased variety in the data set. Then it adds in all the preferences set from the Spotify-based parameters and returns that. This then gets ran and it will plot that fitness. I am currently actively working to adjust this, and it will likely add some new elements in the very near future. But that is the basic structure of this Jack algorithm. I do have you guys have a wonderful rest of your day. Goodbye.